All right, this is Open Up Resources. It's really going to be Unit 1, Lesson 9. We just have a little brief intro that we're going to use from Lesson 7. Lesson 7 is called Scale Drawings. And it shows these three images here, saying these are drawings of a school bus, a quarter, and the subway lines around Boston, Massachusetts. And these first three drawings are indeed scale drawings of a school bus, a quarter, and the subway lines. And when we look below, we can see that we still see a school bus, a quarter, and what appears to be the subway lines for Boston, Massachusetts. But these ones are not scale drawings. So, students in class have already discussed, perhaps you should pause the recording so that you can give yourself a chance to think. What do you think a scale drawing is based on this information? And students in class are ready to respond, so let's see those hands now. Great, thank you. We'll start with Cambria this time. Yeah, I think that's a good start. It's an accurate representation of the item that we're trying to show. Yeah. Any other thoughts on what a scale drawing might be? Basically, everyone's thoughts, right? How is this related to what we've been talking about previously, which are scaled copies? How is this related to scaled copies? Joshua? Yeah, they're going to be scaled copies. They're going to be hand-drawn. One other thing that's going to be different is this the entire picture of a school bus? No, so it's kind of like taking a two-dimensional or a side of the school bus and representing it in 2 dimensions. Just like this. This isn't the whole quarter. The whole quarter, it has a little edge with ridges, and there's a backside and everything else. So they're like 2-dimensional versions. But they are still very, very much the same as scaled copies. So all the things that we've been learning about scaled copies, for example, scale factor taking us from one to the other, angles being preserved, all of those things are going to hold true for scale drawings. And with that in mind, we're now ready for Unit 1, Lesson 9, which is now going to be us creating scale drawings. We're going to start with another quick little warm-up, another number talk. Without calculating, decide which quotient is larger. So I don't want you to do the long division algorithm. I don't want you to be typing these into your calculator. I want you to just use some mental math skills. Look at how these problems might be similar or different, how are they related, and try and figure out which of the quotients is going to be larger. And again, this is just these two, so 11 divided by 23 and 7 divided by 13. Which of those two is larger? And then you'll repeat that. Which of these two is larger? Which of these two is larger? Pause the recording as you give yourself a chance to answer this question. And students in class are going to work with their groups. Ready, set, pause. All right, what are your thoughts? 11 divided by 23 or 7 divided by 13? Which one is going to be larger and why? Thank you for your participation. Let's start with Oren. And how do you know that? I know, but what was the mental math that you did? Like, what were the thoughts that were going through your head to help lead you to that conclusion? Mm-hmm. Okay. Any other thoughts on how they came to that conclusion that 7 divided by 13 is larger? Let's go to Grant. Mm-hmm. I'm going to pause real quick. Is it equivalent to 2? Nope. 11. Even going back to this one, 11 divided by 22. If I write it a different way, there we go. That's better. Yes. So instead of 2, it would be 1/2 on both of those. So yes, this is close to 1/2 and this is close to 1/2. You're absolutely right. So how do we know which one is larger? Mm-hmm. Mm-hmm. Good. Okay. So let me summarize that for the microphone for the recording. What we're seeing is both of these are really close to 1/2. If I just change 23 to 22, it's going to be 1/2. If I just change 13, oops, I wrote that wrong, to 14, it's going to be 1/2. But when I make the change in that divisor, when I make the change to a smaller number, that means it's going to be, what did you say? I'm having a brain fart here. When I'm taking the same amount, 11, but dividing it by a smaller number, yes, our new answer is going to be bigger, exactly, making this one a little bit smaller than 1/2, right? And this one, when I take the divisor of 13 and now make it bigger, this new answer is going to be smaller than the original amount. Therefore, this one is going to be bigger. Another way to think about that, I'm going to try and just summarize it one last time. 11 divided by 23 is really close to 1/2, but it's a little bit less than 1/2. 7 divided by 13 is really close to 1/2, but it's a little bit more than 1/2. 1/2 would really be 6.5 over 13. We have a little bit more than that. So that is how I would do that one. Let's move on to the next one. 0.63 divided by 2, or 0.55 divided by 3. What are your thoughts here? Which one is going to be greater? Joshua. Okay, and why? Okay, that's a great way of thinking about it. We're kind of thinking about this instead of 0.63. Let's imagine it's 63. 63 cookies that we're going to split among only 2 people. Or instead of 0.55, let's think about it as 55. 55 cookies that we're going to split among 3 people. So we have less cookies that we're going to share with more people, or more cookies that we're sharing with even fewer people. I think that's a great explanation. And then it doesn't really change a whole lot when I include that decimal place in both of those numbers. Great thoughts there. And the last one, 15 divided by 1/3, or 15 divided by 1/4. Which one is going to be greater? Happy to see all these hands. Sophie. Okay. You're close, and I really like your thought, but here's something interesting that's happening. We're dividing by a fraction this time. When we divide by fractions, some interesting things happen. Do you remember any of this from previous years? A few hands are up. Let's see. Let's check in with Luke and see what you think there, Luke. Yep. You guys remember that? Yep. That's that reciprocal word again. When we divide by a fraction, we can complete this division in a much easier way if we change it to multiplying by its reciprocal. And the reciprocal of 1/3 is 3. So this one, following that same procedure, instead of dividing by the fraction, we can complete that same calculation much simpler by multiplying by the reciprocal. So now that you see it that way, Sophie, I'm sorry. Sophie, which one would be bigger? Yeah, dividing by 1/4. I know, kind of interesting, right? So here's where we're gonna try and really, truly try and make sense of that, okay? Don't worry about it being 1/3 and 1/4. We have the advantage on this one that we at least have the dividend as the same number. So again, if we follow our strategy here with cookies, we have 15 cookies no matter what, right? We're gonna split those 15 cookies among a small number or a smaller number. So those same 15 cookies can go to this small amount of people or even fewer people, which means now each person gets even more cookies. So following that same sort of idea, I like cookies shared with friends, mostly because I like cookies, but also it really helps me understand the division problems a little bit better. Okay, great. You guys, like I said, you guys are great minds with that number talk and that numeracy. It's not super duper related to the lesson, but having some number talk is always a good thing. So bedroom floor plan. Here is a rough sketch of Noah's bedroom. This is not a scale drawing, right? We saw what scale drawings were. They're very precise, they're very accurate. And do you think that his walls are really going to be swooshy like that? Okay, so it's not a scale drawing. It's just a rough sketch. Noah does want to create a floor plan that is a scale drawing. The actual length of wall C is 4 meters. So on this rough sketch, I'm going to start labeling. This is 4 meters. To represent wall C, Noah draws a segment that is 16 centimeters long. So when he actually draws it on his own paper, and I know you don't have rulers in front of you, but when he actually draws it, he wants it to be 16 centimeters, okay? So what scale is he using? I want us to be careful about this. Whenever we've answered this question before, we've asked what is the scale factor? But we can't think of this exactly the same as a scaled copy and scale factor. What is the scale he's using? Talk with your groups and see if you can make sense of that. Figure out how to answer. Let's come back in just 20 seconds. We're not even going to pause the recording. 20 seconds, ready, set, go. Okay, and what do you think? How would we represent the scale? What scale is he using? Carter? I know, give me a second to write it down. 1 meter to 4 centimeters, right? That's what you said? And now that it's on the board and everyone can see it, tell me how you got there. What does that mean? Good. 1 meter in his actual room is going to be represented with 4 centimeters on his drawing. Where did the 1 and 4 come from? Because I only see a 4 and 16. Where is that 4, or where is that 1 and 4 coming from when the numbers here are 4 and 16? Tanner. Okay, very good. So you're recognizing that 4 and 16 each have a common factor, a number that can multiply to get to 4, and that same number that can multiply to get to 16, and that is 4. So 4 has the factors 4 and 1. 16 has the factors 4 and 4, and we can see that each of them have that 4 in it. So that's me dividing out that 4, and what's left? 1 meter. And when I divide out the 4 here, what's left is 4 centimeters. That's exactly right. So again, we can see that this is related to that concept of scale factor, but we have to represent a scale in a scale drawing a little bit differently. We have to show in real life it's this, and we're representing it with this in our drawing. Find another way to express the scale. Actually, we just did that. Originally, we could have said 4 meters to 16 centimeters, but we can also simplify it, taking out the common factor, and we get 1 meter to 4 centimeters. Are there other ways? Find at least 1 or 2 other ways that you can do this quickly at your tables so that we can have it for the recording. We're going to pause the recording in the meantime. Ready, set, go. Okay, and now give me at least 1 other scale, maybe 2 more scales. What else did you come up with? Leroya. Good, and this is where we can really start seeing things come together. How did you come up with 2? What did you do to get that 2, Leroya? Okay, yes, we can divide by 2. So maybe in the beginning, we don't recognize that they have that common factor 4, but we say, hey, they're both even, so I can divide by 2. That's how we can get there. Nicely done. Notice that we're dividing them both by the same amount. We're dividing each one by 2. I think that's probably good. Just for the sake of time, let's just continue on. The actual lengths of wall A and wall D are 2.5 meters and 3.75 meters. Let's add those to our rough sketch. A and D are 2.5 meters and 2.5 meters. Did I do that right? A and D. Oh, got it. D is 3.75 meters. Determine how long these walls will be on Noah's scale floor plan and explain your reasoning. Okay, let's come back together and let's discuss how long is wall D going to be in this scale drawing. How are we going to use all the information that we've already done so far to figure out how long it's going to be in the new drawing? Trace. Okay, why? That's great. Tell me why. Why did you multiply this by 4? Yes, but why 4? Why not 5? Why not 6? Why are we multiplying by 4? Let's go to Gideon. Yep. Exactly right. So it's one of those things where it's almost too obvious that you forget exactly how to explain it, right, Trace? So what we see here is in our original, the 4 meters is represented with 16 centimeters. How does that 4 change to a 16? And this is where we can kind of relate it to our scale factors. How does that 4 change to a 16? We multiply by 4. We can see it down here as well. When we simplify it, how is this 1 changing to a 4? We're multiplying by 4. How is this 2 changing to an 8? We're multiplying by 4. Since we are seeing this relationship of them multiplying by 4, we can represent all of that with a ratio. So 1 meter is changing to 4 centimeters in our drawing. Focus just on that number part there. That number part is changing because that 1 is multiplying by 4 to become a 4. So in our drawing, when we now have 3.75 meters, what is going to happen back in equivalent ratios last year? You know that whatever I do to the top part of that ratio, I need to make sure I do to the other part of that ratio. So I'm also going to multiply by 4. So we can see that this is not anything new. This is the same concept of equivalent ratios. We're just representing it in our scale drawings now. So 3.75 multiplied by 4. Remind me one more time what you said, Trace. You said 15. Yes, 15. And you also said that we're changing the units because it's meters over here when we're representing the actual one. And when we're representing it in our drawing, we're changing that unit to centimeters. That's great. Let's repeat that same process. 1 meter to 3.75. Oh, not 3.75 this time. It's 2.5. So this is our actual bedroom that we are now changing to the scale. And I can still see the same thing. That 1 is changing by multiplying by 4. So I'm going to change this 2.5 meters, multiply it by 4, so I get that new amount, and then I will have, anyone who has it calculated, thank you, Bella, 10. And again, actual room is meters, scale is in centimeters. For you online learners, you will see that part of this lesson does include an applet. And so you are allowed to make this scale drawing using the applet. Let's see how that is going to work. It tells you use the point tool. You can make points using this tool. Add the segment tool. That's going to look like this so that you can actually draw the walls of Noah's bedroom using that scale. So to do that, you're going to click on View Applet. It's going to open up in a new window, and here is that applet where you can see here is wall C, which is 16 centimeters. We now know how big wall, I already forgot what it's called. Wall D is 3.75, but we multiply that by 4, and that's how we get 15. So we can actually do that to be 15 centimeters. I'm going to use my segment tool. Well, let's see. If I'm at 0 and it's going to go up to 15, I can put a dot there. That way I know I'm doing it right. So that's the segment or the dot tool. Maybe I'm still on segment. I'm not sure. There we go. Drawing it down there. Now I've drawn wall D. We can continue that process. You can draw the entire bedroom. Go ahead and practice that now. Pause the recording so that you can do that. That's it for that problem. Let's move on to the next one. Are you ready for more? If Noah wants to draw another floor plan on which wall C this time is 20 centimeters, would 1 centimeter to 5 meters be the right scale to use. Explain your reasoning. I'm going to come back over here and I'm going to copy this image onto the new screen so that we can have that information where we need it. There we go. Ooh, that copied really, really, really big. So we know the actual measurements of his walls, and now he's creating a new one where wall C is going to be represented as 20 centimeters this time. He thinks that the scale is going to be 1 centimeters to 5 meters. Is that the right scale to use? Now that we have this visual to make sense of it, I want you to talk with your groups or pause the recording and give yourself that quiet think time. Ready, set, go. Okay. Is 1 centimeter to 5 centimeters the correct scale to use? Luke, thank you. Okay, can you explain, please? He said no, but I need some more than just no. Mm-hmm. Why don't we have 5 meters to do it with? What do you mean by that? Okay, so you're saying the wall is only 4 meters long, so I can't use a scale that involves the number 5. That is kind of true, but this also isn't a good scale for a different reason too. What are some other reasons why this wouldn't be a good scale? Not just because this is a 4 and we're saying it's 5. Tanner, what are your thoughts? Yes, so one way that we could resolve this issue is if I decide to switch these. If we said 5 meters to 1 centimeter, that would be more appropriate because we're saying 5 meters in real life is going to represent 1 centimeter in the drawing. So coming back to this one, what we're saying is 1 centimeter in the drawing, we're going to represent, 1 centimeter in real life, we're going to represent with 5 meters in a drawing. How much fun is that going to be? Think about that. 1 centimeter in real life is going to be 5 meters. Is your paper 5 meters big? No, not even close. You would have to have a very, 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 very large paper. This would be a huge enlargement and it doesn't really make sense. What we would really need, if this is 1 centimeter to 5 meters, let's just say a wall was only 20 centimeters long, which it's definitely not, but 20 centimeters, you guys can see that on your ruler. 20 centimeters is less than a foot, right? In this drawing, 20 centimeters would have to be represented with 100 meters on a drawing. Imagine 100 meters. Is that pretty big? Yeah. So part of the biggest issue, I would say, is not so much that the wall is 4 meters and he used the number 5, but more that he reversed the parts of the scale. We're going to continue this lesson, this activity of the 2 maps of Utah. It's going to take some time, so we're going to continue that in a different lesson and a different video. So that's it for today. Thanks for watching, and we'll see you next time.